Let's just start. So today we'll study IP layer security. These two things we have already discussed, that malwares remain undetected for many years. Okay, and these are the contents that we will study today. We'll start with internet design goals. Then we'll look at layered architecture. Then we'll come to network layer. Layer 3 security and flaws, and IP layer spoofing attacks. Okay, so these are the ones which we'll study. Okay, all right. So internet design goals, right? We discussed this several times, and I'm repeating it again because once you understand this, then you know that you'll have to do something about securing internet. Okay, and that applies to each one of us. If you think that, like in PSTN phone, you just connect the box or telephone and you don't have to do anything to provide security over your telephone box, because the network or the infrastructure provides the security. Okay, and internet on the other hand is like a pipe, which is a leaky pipe. Okay, so internet by itself does not provide any security. Now it is left to the endpoints or end users to provide security if they want to, and that's the reason it is very important that at the end you have to have adequate mechanisms for security. For example, firewall, or you should also have you should use VPN, you should use encryption, and then you should have some kind of malware detection software. Okay, all right. Now what is internet designed for? Start from the top. You can see first point is interconnection. It basically provides connectivity. Okay, it's beautiful design because it connects any kind of network, and a layer 1 and layer 2 could be anything. It could be Ethernet, ATM, or whatever, but layer 3 is always IP, and then TCP and UDP and so on and so forth, right? So it just connects different networks. Then failure resistance, if any node in between or any router in between can fail, still packets will go through, packets will find route, or network will reconfigure itself, or routing mechanism will find out new path. It supports a multiple types of services. Okay, because on the top it simply is a network. This transports IP packets, right? And beyond that, any kind of service then can be ported onto this kind of packets, right? Okay, it basically transmits zeros and ones, and zeros and ones can be coded by any application. Management of resources, it does beautifully, is very cost effective. Now the cost effectiveness comes from the fact that it's just plain simple packet transport technology. So you can see that we can get hundreds of megabits per second kind of bandwidth at very low cost. Okay, we hardly pay 1,000 rupees and get that kind of bandwidth. Okay, all right. Low cost, low entry cost, anybody can have internet, right? I mean, like even the people who are earning as less as 10,000 rupees a month are using internet. So it's not the thing, it's not the facilities given that's available only to rich people. Okay, and it does accountability of resources. So all these are the all 8 points are basically design goals of internet. But there was absolutely nothing about security. Okay, internet has not been designed for security. It's designed for connectivity. As you can see, the first point, second point is designed for implicit trust. And so basically the whole idea is that now if it's not designed for security, then you have to provide security at the end. By what? If you look at the third point, is by encryption, authentication, end-to-end arguments or end-to-end features or protocols in system design. Okay, basically at the end. So once your packets are traveling from your router or your laptop to your router, Wi-Fi router to ISP, once it leaves your router, you don't have control, and all in between, whatever it is unreliable, or it does not provide any security. ISPs don't provide any security. If you read their, whatever, when you take a service, ask them to send you terms and conditions, and will clearly mention that it does not provide any kind of security. Okay, now we are going to look at layer 3. In order to do that, let's look at first, I mean, this we have studied n number of times, but I think is worth repeating. So on the top we get HTTP packet. HTTP message is nothing but a stream of bits, and that goes into TCP if you want reliability. Now what happens is that on any machine, when we say IP, every machine has an IP address, like your laptop has an IP address, right? But on your laptop you can run n number of applications. Actually, right now I'm running 5 or 6 applications, which includes WebEx, which includes email services, which includes browsers and so on and so forth, right? And each is once, okay. So now packets may come to your machine, but how does machine know which application it has to go to? Okay, then we define, and then these applications like browsers or multiple browsers are mapped to different ports. Suppose you have 3 windows in a browser that are open. Packets that are meant for first window should go to first window, so it means that it must be given some identity, and that identity is nothing but a port number or logical number, which we call it port. Okay, now on server side these ports are kind of fixed if it's a stateless machine, like here if you see the outer packet, HTTP message goes inside TCP packet. Okay, and then we write port number 1234 from port number 1234 to port number 80. Okay, and then when it comes to IP layer, then we write machine address, right? From source machine address, which IP is 1234, to destination of IP address is 5678. Okay, okay, and now this packet comes to Ethernet level, and wherein we write Ethernet from address, that look at the top, from address is source address of that is Ethernet, and destination address is here on the second line from the top. You can see address of the next hop. Okay, all right, and so next hop means that there may be routers in between. Okay, all right, yeah, just a minute. Okay, all right. And then this Ethernet packets gets converted in bits and bytes, and then finally comes to other end. Okay, now this is, we can see that MAC address is changed here from the previous MAC address, right? The MAC address here is very different, and MAC address now is different, right? What is the reason for that? Because you see, there may be multiple routers in between. Okay, and lower and layer 2 of that is Ethernet. So it just from a router or switch before the final destination will have some sender's address, and the destination address will be destination machine's address. So we have to from and to Ethernet addresses which are different. Okay, all right, and now this packet is delivered to IP layer. from Ethernet layer to IP layer, from IP layer to TCP layer, and then finally it becomes whatever bit stream. Okay, this is how it works. This is what we have studied, right? So now we are looking at the third layer, which is IP layer. When we say IP layer or network layer, what does it consist of? Okay, it consists of, first thing is that what is IP in general? What is the format of IP and how should it be interpreted? That we call as IP protocol. Okay, and second thing is that how these IP packets are routed. These are called routing protocols, like BGP, OSPF, ISIS. These are three main protocols. Okay, and then there are some supporting protocols like ICMP. Okay, so these multiple protocols are basically layer 3 protocol, and main of course is what we defined is IP or internet protocol format of IP. Okay, all right. So basically these are the three things that network layer functionality. Look at the last bullet point. Network layer functionality includes internet protocol, routing protocols, and supporting protocols. All right. Okay. Good. So this is it. Basically, we know now that we need layer 3 for routing of packets, because the Ethernet or layer 2 network cannot expand to the whole, all machines on earth, okay, or even in space. Okay, so now the Ethernet or local area networks or layer 2 networks has to be restricted within some area, because we have seen that route, switching table size will go up. That's first thing. And secondly, address is a flat address. It's a 48-bit address, Ethernet address, which does not say which machine is where. Okay, and in order to send frames, we'll have to broadcast in the beginning, and if there are millions of machines, billions of machines, then it's impossible, right? So that's the reason we cut short the size of Ethernet or the size of layer 2 network, and then use routers. Okay, so basically we have multiple routers until your packet reaches to destination. All right, and this diagram we have seen, your packet starts from A on the left side and goes up to D, which is on the right hand side. Okay, and these links, it goes over various layer 2 networks, and links can be of different types like Wi-Fi or Ethernet or whatever. Okay, now one thing is there, that packet must consist of three things at least. IP packet, first is source address, like your mother's laddu packet that you may get on Diwali day. It comes from her own address, house address, name and house address. Then destination, that your address, physical address. That's two things that's important, right? And of course the contents, like laddus or data that it may contain, right, in case of IP packet. Alright, it is very similar to what we did in layer 2. But one interesting thing here is that unlike your mother's laddu packet, which cannot be split into small number of packets, if courier guy is not able to send the packet, suppose your mother sends 100 kg laddu to you, then courier guy cannot split into 100 packets of 1 kg each. But however, in IP network, if there is a link or layer 2 protocol which cannot support very large size packet, then it will fragment the packet into a small number of packets and then put the similar header. Okay, and some way such that these can be reassembled. So packet can be fragmented into a small packet number of packets on the path. Okay, and at the end it has to be reassembled back. Okay, all right. Router's functionality we have seen, it just forwards it to the next router on the way, and then that router has also information about the path, so it can send it to the next one and so on. So packet reaches at the end, but it's not necessary that all packets will be taking same routes, because the understanding between router can change in between, or some router may become faulty. Okay, all right. So this is the format of IP packet. Now we have shown this in basically in the form of rectangle or rows. Actually, it's nothing but a simple string of or a stream of bits, right? So essentially, from the left, you can think this is left starting from left hand is going up to right hand, right? But however, we will have to fit all this information, so we show uh, it in rectangle form, right? So basically, if you look at the first row and last bit is corresponding to total length, and then the last bit of this and the next bit will be beginning of next row, that's identification, right? So essentially nothing but string of bits, right? Okay, but here we have shown it in this form. So now there are various fields like version, header length, type of service, total length, identification, flag, fragment field, time to live, protocol, checksum, source address, destination address, and data. So three things that are very important: source address, destination address, which are of 32-bit in IPv4, and total length. So now you can see it in this way. The first is version number, whether it's IPv4 or v6. What is the length of the header? Header is something that contains metadata, almost up to the option field here, like source IP address, destination IP address, and we can see uh, option field here, right? So that is something overhead, okay, or header. And below that is payload data. You can see at the bottom part of the diagram, which actually contains the important stuff like laddus inside. All other things are actually source, destination is overhead. Okay, all right. Type of service, we can define various types of service that the package should be given priority, like it can be diff surf, etc., etc. Will not get into it. What is the length of the header? All these fields, which is metadata, what is the length of that? That's given in length field. And then we have time to live. A packet cannot remain in the internet for many years or many minutes or many days. Okay, so basically, in order to limit the lifetime of packet, we'll say that how many hops it can go through. Okay, so TTL defines the maximum number of hops, and whenever it reaches to next router, it reduces it by 1. So sometime or other, when it becomes 0 and destination is yet not reached, then that router will drop the packet. Okay, okay. The upper layer is that this IP layer payload will contain TCP data or UDP data, right? So it will define whether it's a TCP or UDP. And then we have source address, destination address, and so on and so forth, right? So this is how it works. And of course, we can see this packet can get fragmented. So the second row defines how it can be fragmented and reassembled back, right? So every fragment will be given a number, which is 16-bit number, and then finally it can get reassembled. So we have all this. All right. Okay. Any question? No? All right. So now we can have IPv6 is 128-bit address. Okay. And it's globally unique. Okay, see, IP addresses are all globally unique, right? So your whatever IP address your machine has will not be same IP address with some other machine. Of course, we can share this using some mechanism that will not study now. Okay, but in general, think that in order for any message to reach to other machine, it has got to have unique address. How do you provide uniqueness? Is left to individual, right? So you can have, say for example, ideally each laptop should have IP address, fixed IP address, but that's not so. Now we can have some kind of sub addresses also, right? Like, so we'll not, so based on some port, etc., etc., we'll not get into it right now. But in general, right now we assume that each machine is having some given IP address which is unique. All right. So now these points we have already discussed, that key responsibility of IP layer is end-to-end delivery of packet. There is no guarantee on message ordering or delivery. This we have already seen in through simulation. It only does routing. Okay, each host knows the address of one or more connected routers or gateways, and then hop by hop the packet reaches to destination. Packets can get split or fragmented, and at the end it has to be reassembled. And then very important point is that somewhere in between, if something happens to packet, then that router has to inform back the source machine about what has happened. Okay, that's called ICMP messages. And of course we have seen time to live. Okay, all right. Now security, there is no concept of security. It means that there is between one router and another router, there is no encryption. Okay, and there is no error correction also. So if packet one in between, sorry, router one drops a packet, okay, drops a packet, then it has no responsibility of informing previous router about it and asking that router to resend it, right? But however, if packet is dropped at a router, it will inform the source that something has happened. Okay, all right. Okay. So packets can be lost in between, packets can be corrupted, and packets may be delivered out of order. And whose responsibility is then? Because when you're sending a file from one end to other end, file has to reach properly. Even one bit cannot be wrong, right? So how do you then reassemble the main packet? You reassemble the main packet because you will have to provide reliability mechanism at the end. You cannot depend on internet to provide you reliability, right? Now, what is the weakness of IP protocol? Is based on the trust. That's the weakness, right? It's based on, it assumes that everyone, every node that's running IP will be honest. Okay, and this is the problem with in general with network world, right? Because protocols assume that every other end will be running the same protocol. The weakness we can see, there is no authentication of IP source address. Okay, what does it mean? What does it mean? Anybody? Yeah, try. Are you alive? This point we have discussed several times, and if you can't answer it, then hello. Tushar Nagar, are you there? Tushar Nagar, are you there? Can you switch on your cameras? Let me see how many of you are sleeping. Can you switch on your cameras? I'm sorry if this is the way you want to attend the class, then I will simply send PPT. Okay, thank you. Some of you did that. I'm grateful. Okay, you tell me now. What do we mean by no authentication of IP address? See, when we say, yeah,
Like the sender can use a random IP address, na? Uh, We can be sure
Right,
that.
absolutely right. So why did you take so long? Thank you. So basically, if I receive any packet, how do I know it has come from genuine source? Anybody can fake anybody address, right? You can get hundreds of packets, hundreds of sweet packets in your hostel room sent by some criminal that may have poison, and he may write any source address. He can say that from Prime Minister of India you are getting this packet, sweet packet. How do you then ensure that it actually comes from Prime Minister of India? So there is no authentic. Anybody can create any IP packet and send it over internet. That's the weakness of IP layer. Okay. Now, what is IP? Second is IP spoofing. Okay, I again similar thing, right? Anybody can spoof my address and send it to anybody else. And can it result into denial of service attack? Yes, we'll see how. Anybody can do man in the middle attack. Okay. Now there is anybody can send IP packet to anyone with any address. Okay, so all these are good or bad. It's good because it gives flexibility. You can design applications to use these features. It's bad because there's no security. Okay, so there are large number of threats on internet, and these are to eavesdrop, denial of service attacks, modify packet, spoof what's going on, traffic hijacking. Like what happened is the routing protocol was changed by Chinese spies, the Chinese cyber criminals, and then the whole world's traffic went through there because again this routing protocols, BGP, etc., are based on trust. And a router in China can advertise, I have route for rest of the world with minimal cost. Then all routers will accept that, and then they will send packet to this Chinese router, and then Chinese router will do whatever it wants, right? Okay, so all these are possibilities. So first we'll look at IP level vulnerabilities, then we'll see these supporting protocols like ICMP that can also be exploited. And then of course these routing protocols, as we have given China example, the BGP, etc., can also be exploited. Okay. Okay, so first thing we'll look at is network packets pass through untrusted hosts. Now, when you send your packet IP, your machine is sending the packet, creating IP packet, giving it to Ethernet. Ethernet sends it to the router, and router sends it to ISP. And now everything else is not visible to you. So router in between by ISPs can look at what's happening. Actually, there is no guarantee that they are not looking at it. Actually, it happens. Okay, they can look at what's happening, like eavesdropping. They can sniff the packet, they can store the packets, and so on and so forth, right? So you as an end user has to always assume that the ISPs are not providing you secure services. Second thing is IP packets are public, IP addresses are public. Everyone knows everyone else's IP address. You can always find out IP address of somebody else, right? Right, remember old times there was a dictionary of phone call numbers, and like PSTN used to give you 1,000-page dictionary, yellow page dictionary, right? Remember that? Ask your parents, they will tell you. Now, why they were telling my name, say my name and my phone number was written, everyone's name in the country or city, and then phone numbers were written. Why was that happening? It happens today, I will be very angry, right? Because that time the trust level was high. What will happen if somebody makes a some vague phone call to you? It will be 1 rupee the person has to pay, and possibly will be caught. Okay, now that same thing is not good, right? If somebody publishes my mobile number, it's not good. So ideally, you should never publish your mobile number anywhere. Okay, nevertheless, okay. So IP addresses are public, so attacker can exploit that. And there is no way to check who's sending this packet. I receive a packet. How do I know it has come from the source IP source address that's written there? Okay. Of course, through Ethernet address, I can come to know who has sent me, who is the source, just previous hops, Ethernet address I can track, and that way possibly one can trace the route if required by police. Okay, but to my machine, if something comes from somewhere, some IP address, I have no way to know. So routing, all routing protocol design assuming that everyone is trustworthy. Okay, all right. So now some protocols were designed. I mean, you would have heard of this R login, remote login. So you can do remote login to a machine, and then you use that machine, right? A server or somewhere, right? So we used to use R login. Now, R logins are based on the IP address. So my IP address, suppose 1234, and that router, that machine will have 1234 as a identity, that anybody comes with 1234, please allow that. It's like this. Okay, it means now anybody can fake 1234 and can log in into that server, right? So all these protocols which were designed in the beginning, just about 10 years back, people have been using these, are now to be discarded, right? We cannot use this. Okay, and of course there are features like fragmentation and broadcast have been exploited. So now let's, for next 10-15 minutes, let's look at some of the very basic uh, attacks. First is IP address spoofing. Use the wrong IP address or forged IP address, right? You can, so this purpose is to conceal the identity of sender. What is it going to, why? So you can send some malicious thing with some different source address. Okay, all right. And of course, you can use somebody else's IP address to use, bottom, if you can see R login and so on, which are, if some machines, some servers are still using R login, you find many such machines in the world which are using this obsolete protocols like R login, RSH, R host, etc. Then you can always, and that server will have certain number of IP addresses that are allowed to log in, and you should be able to log in by faking those IP addresses, right? So when you use the wrong, attacker uses the wrong source IP address. If you look at the attacker's address, IP address 200.1.1, but creates IP packet with 150.1.1.1 and send it to a server which is 100.1.1, 1.1.1, and then when it replies back, to the source address that has received, which is 150.1.1.1. So it will go to a victim's machine. Now, can this be exploited? Yes, this can be exploited. Okay. Now the attacker can give a source IP address of non-existing IP address. Then server will respond back to some IP address of a non-existing machine, or basically it is unused IP address. So what are you going to get out of it? What is the attacker getting out of it? Basically is wasting resources of this server, right? Okay. So how can you, what are the mechanism to find out whether packets have genuine IP address or not? There aren't many, by the way. Okay. Some basic things you can do is that if you have received or consider a firewall or security guard, okay, and who has received a packet. Suppose a courier guy comes and then security guard intercepts that, and then that courier has address, sender's address of a person who is inside the campus. Then security guard will know that of course the person resides inside. How can this be? Packet is coming from outside, right? So it will block that. So we call this ingress filtering. Okay. Okay, and then egress filtering. Suppose you are sending a packet, fake packet to somebody, writing somebody else's address, which is not from inside your organization or your institute. Then the security guard will know, okay, some guy is trying to fool. It means a malicious person inside. Okay, that's called egress filtering. And of course, you can higher layer protocol like TCP uses sequence numbers. Okay, now sequence number also goes along with packet. So while at IP layer you can change the source address or whatever, but it's very difficult to find out what is the sequence number. Okay, so we'll look at this technique when we study TCP. All right, so these are some way the IP packet can be manipulated. Okay, now let's look at ICMP. What is ICMP? Anybody? Anyone has idea about it? It's called Internet Control Message Protocol. This is supplementary protocol or associate protocol to help IP. Okay, have you done ping to a machine, ping to some IP address?
Yes, sir.
Right? Ping uses ICMP. Okay, all right. So when we say layer 3 or network layer, that consists of essentially IP, then ICMP, IGMP, and routing protocols. Okay. Now, why do we need ICMP? When your machine has sent an IP packet and it goes through multiple routers, and some router has a buffer full. Okay, if buffer is full, then packet will be dropped. If packet is dropped, then that router will inform your machine that I have dropped the packet. Now, internet does not give you guarantee that packets will reach reliably. So now your machine has saved that IP packet, you can resend it if you are using TCP. Okay. So what happens is that node or that router will send ICMP message back to your machine, right? So ICMP is nothing but is a collection of error messages that are sent back to the source host whenever router or host is unable to process the IP datagram. For example, if destination machine is not reachable because of some reason, right? Or the machine is off, then your machine will receive destination is not reachable. Okay, if packet is fragmented in between and destination is not able to reassemble it, your machine should get a message. Or when TTL has reached 0, it means the number of hops that in the beginning you defined as say 5, and there are 5 routers in between, and then 5th router it becomes 0, then it will discard the packet, but it will send you a message, right? Okay. Or routers are intelligent and router may inform you machine that there is a better route available to destination, rather than me using as some gateway, you can use other gateway. Okay, that's called ICMP redirect message. Look at third line from the bottom, and then you can do ping, aliveness of a node, right? You can ping a node and get the information whether that machine is up, or you can do the trace routing, and all these are the things that you can do using ICMP. So basically ICMP is a helper protocol or supplementary protocol. So ICMP also uses IP header, right? IP protocol or IP packet. So we can see the format here. There's a IP header and then ICMP message. Okay. All right. So basically it has type field, important format is that it has type field, code field, and checksum, and of course some additional information will be there, right? Type and code, basically 8 plus 8 bits define what is that ICMP message. Okay. So for example, you can see 00 defines echo reply or ping reply, that comes from machine. Similarly 80 here, look at fifth line from bottom, it defines echo request or ping request. You send a ping, then you use ICMP and then put a code 8 and 0 and then send it to some server, and then of course in IP destination address you have to write. Okay. Similarly, destination, second row from top, you can see destination network unreachable, then it is 30 and so on and so forth, right? TTL expired is 11.0, bad IP header is 12.0, then destination host unreachable is 3.7, and all this you use, right? So basically host can also send, host can query like ping through ICMP, and then host has to reply through ICMP message like ping, for example, right? So these are example of ICMP queries: echo request, echo reply, timestamp request, and timestamp reply. You can actually ask what is the time in a server, right? And you can get the response back. Okay, so for example, ICMP echo request, and then you have ICMP echo reply. All right. Okay, then timestamp request, and then timestamp reply. All right. And then of course there is something wrong happens in the router. You can see right hand side the router, if the packet is dropped, then it has to inform the host about what has gone wrong, right? For example, initially host sends an IP datagram, that's you can see on the top, it reaches the host, a router in between, and router will inform back the host sender what's gone wrong, right? Okay, so this is a format. Okay, you can read all this. Okay, all right. So for example, ICMP, you send a client sends a IP packet to, say for example, port 80, which is HTTP port, and that's not working for some reason, or that app is not working, then it will respond back that port is unreachable through ICMP message, right? Now the question is that how can this be exploited? Can we exploit this? Another 2 minutes we'll finish. Now again, there is no authentication on ICMP message. Anybody can force this ICMP message. For example, redirect message, fragmentation, destination not reachable. So we'll look at ICMP redirect message. Okay. So this is, we have seen in case of LAN, all IP messages, all messages go through a gateway, because every subnet will have a gateway, right? Okay. So now host is sending, A is sending through gateway. You can see blue line here. Okay, but there is an attacker, and it sends a ICMP redirect message to host A that there is a better gateway available, and that better gateway has IP address of attacker. Now note that anybody can create this ICMP message. So what this attacker, which is shown in the here at the bottom, has created ICMP message, sent it to host A that there is a better gateway available. Okay, so now host, so okay, so this attacker sends this spoofed message, there's a good gateway is available, and now this host will think that this attacker IP address is a good gateway. This attacker will do receive this packet and then manipulate it and send it through good gateway. Okay, in this way it can do man in the middle attack. Okay, second is the spoofing attack. Now here attacker, now idea is that victim's machine should not work, right? Or it should have denial of service attack, DOS attack, right? So it can do smurf attack. It will create large number of ICMP packet. Okay, and it will have source address in those ICMP packets. So say for example it does ping. Okay, it has source address is destination or the victim's address, IP address, and destination address is a broadcast address, any of the machines in the internet. Okay, so basically, okay, so source address is this address, address of victim at the right hand. Okay, and destination address is broadcast address, the address of all these machines, right? Broadcast address, it will go to all possible machines, right? And then it will send a packet which will be broadcasted to all, and all machines will respond of the ping to a machine whose source address is given by attacker. Source address is victim's machine, right? So all this reply will go to victim now. Now, if these packets are in millions, then these victims machines will not work, right? So now this attacker can use botnet. There can be millions of bots even in your router or your mobiles, okay, and send this kind of message, and these bots will respond back to victim, and then this victim's machine will be has to, when you send the packet to a machine, the machine has to receive the packet and process it, right? So this is called denial of service attack. Okay, now there is another attack called ICMP, ping of death attack. Essentially, a ping packet is large, if ping packet is larger than 64K, then on in between it will be fragmented into small packets. The destination machine has to receive all these small packets and then has to reassemble them, and in the process of reassembling, its buffer will be full, overloaded, and will crash the system. That's called ping of death attack, right? Okay, so these are the attacks. You can go through DDoS tools that are available publicly and possibly use them to get some kind of feel for them. Of course, you will do attack on your friend's machine or whatever. Okay, all right, so that's all for today. Thank you.